To sports. The Lakers won yesterday in a
Whoa,
close game.
whoa, hold up. First of all, the Lakers aren't even in the playoffs. It's the Clippers, bro. And second of all, this is confidence intervals today.
Ah, man, not again.
Well, confidence intervals are intervals used to predict the population parameter when you don't have enough information or resources to get an exact number.
English, por favor?
A parameter used to check the reliability of a sample's estimate.
Oh, wow, this is interesting. Please explain more.
For example, I am 95% confident that you're going to fall asleep in the next 10 minutes.
A confidence interval is a parameter to check the reliability of an estimate.
Hey, I think I got it now.
Thank you, Puppet, for saying exactly what I just said.
Yeah, bro, but they said it a lot cooler, man.
There are 4 main confidence intervals used: an 80%, 90%, 95%, and 99%. 95% is the most commonly used of the bunch. Each confidence interval has its own specific z-score as seen on this graph.
Thank you, Puppet. Confidence intervals and the z-critical scores are directly related, so whenever you have 80%, you're always going to have that same z-score, no matter what happens.
What about 100% confidence interval?
Connor, if you have a 100% confidence interval, that includes all the possible numbers for the scenario.
Okay, that's making a little more sense, but I still don't get why this is important.
Basically, we are taking the sample's data and checking where the population will lie in comparison to the estimate given in the sample.
I'm starting to get it now.
Those puppets are killing me right now.
But first, we have to make sure the sample that we are using meets certain requirements. It's a little thing called riddles.
Oh, I got this one. What kind of suits do lawyers wear?
No, Connor, not that kind of riddle.
Lawsuits.
Good one, but Evan's right. For one. Riddle stands for random sample, independent, 10%, and large enough sample.
Why do we care about that?
It makes sure we meet all the parameters of a legitimate sample before we decide to pull actual numbers from the data. Random sample, as in it must be a sample that is random with no bias. Independence means that someone's choices or actions cannot be affected by the choices or actions of another individual. 10% means the sample must include less than 10% of the population. Large enough sample means the sample size times the probability of a success and a failure has to be greater than 10.
That's a lot of stuff to remember.
Yes, yes it is.
That was interesting, Devin.
I don't need your comments, you stupid puppet. Anyways, there are several types of intervals. 1 prop z interval, 2 prop z interval, 1 sample t z interval, 1 sample z interval, 1 sample t interval, 2 sample t interval, a pair t interval. Keeping up, Connor?
Keeping up with what? You're not even speaking English, man.
Let's just focus on 1 sample t interval. Look in front of you, and you'll see your favorite thing on that order.
Chocolate cake?
No? Actually sounds pretty good right now, man.
No, your favorite thing is confidence intervals. Alright, so our x, the mean of the sample, is 15.6. Our s, our sample's standard deviation on how different it is from the mean, is 1.8 minutes.
Alright, so now what?
Now, we have to do riddles.
What kind of suits do?
No! The riddles we talked to you about earlier, Connor.
Hey, be nice. But you're right, let's find out if we can continue. It is a random sample, like it says in the problem. The jogs are independent, they don't affect each other. There must be at least 240 jogs in order for our sample to be less than 10% of all the jogs. 24 is less than 30, so it's reasonable to believe that the graph of this model is unimodal.
Alright, so we met all the requirements. Now what?
Math. Do math, Connor.
In this equation, we will use a t-score instead of a z-score. For a t-score, you do inverse. Sorry.
No, just go.
Okay. inverse the area, and then comma, the degrees of freedom. So in this equation, the degrees of freedom would be,
Let's see, what would the degrees of freedom be? Our sample size is 24.
so
It's one less than the sample size.
23!
23! He's right!
So our t-score would be 2.069. Then you just plug it into the equation on step number 4. You will get Julia's 2-mile running time will be between 14.8 minutes and 16.4. So then you go to step number 5. You start running.
I can't take it anymore!
And in other